Okay, here is the next problem we are going to solve. We have, again, the quotient of two polynomials, so a fraction. And remember, from our formulas, all the formulas we have, and we know the solution, we have to look which one of these formulas match the problem we have. So, not these two, this is a power, but no, this is the only one that is a fraction. So again, I'm going to try to fit the same formula. So it's integral 1 over u du, and I know that the solution is natural log of u plus c. Okay, now here my point is I have to match these two integrals, so I have to decide a u. Who can be the u? I have two expressions, 3x cubed minus 1 or x.
3x cubed minus 1.
Yeah, ese puede ser una opción. That could be a solution, 3x cubed minus 1. And the du sería 9x squared dx. Okay. But now I have to check where I have a 9x squared. Do you see a 9x squared in this expression?
No.
There is no 9x squared. So this is not a good choice. Remember, this is a guess and check. So this is not working. Also, if I use u equals x, let's suppose I put these bottoms here, du is dx, what is normal. Okay, the dx is right here, but I have this expression extra in my expression that I cannot cancel out. So I'm in trouble. I cannot apply this directly. So the only thing I can do is do some algebra. I have to do some algebra before try to apply this expression. Then I have to remember my algebra 1, right? My algebra 1, yeah. O sea, algebra 1. Remember that when you have a plus b over c, this is a fraction, you can split the denominator with the two numerators, a over c plus b over c. So this complex fraction is going to be split into easy fractions. Everybody remembers this.
Yes.
This is a distributive property. So I'm going to try exactly the same here, okay? So I'm going to do some algebra before. So I'm going to take this one. This is 3x cubed minus 1 over x. And now I'm going to split 3x cubed over x minus 1 over x. So I have two fractions. But what is my advantage? My advantage is the first expression is going to simplify. It's going to be 3x squared. And the last one is the same. So my integral is going to be the integral of 3x squared minus 1 over x dx, correct? So I split this single one into simple ones. Now, I remember again my properties. My integration rule says that if I have the integral of an addition or subtraction, I have to take the integrals and add them or subtract them. So that's what I'm going to do. So I'm going to take here integral of 3x squared dx minus the integral 1 over x dx. Okay, now this is a power. I have to remember my power rule. The power rule is integral u to the n du m plus 1 over m plus 1, correct? This is the power. I have a power. So this integral is easy. So this is x cubed. How can you check if this is true? If you take this derivative, you must get this one. So the derivative of x cubed is 3x squared. Now, this one is exactly this one, so I don't have to suffer. ln absolute value of x plus a constant. That's my answer. So, what we learn here? It's very simple. If we have something that cannot be applied directly the formulas we have to do some algebra before, try to break this or change this expression by a different one, such that the new one is able to use the formulas we have. So we have to do some algebra, and then we apply the calculus, and then we solve the problem. So this is going to be the difficult part. If you cannot apply directly the formulas you have to guess and check what to do to apply the formulas. That's why integration is more difficult than derivatives, okay? Well, question. Question, no questions? Any
Why is
problem?
the 3x squared turned to x cubed?
Oh, what is the antiderivative of 3x squared?
X cubed.
Incorrect. If you take this derivative, you get this expression.
Oh yeah, you're right.
From the
So,
formula.
or you use this formula, yeah, and then you see that you get x cubed. Okay, well, let's move on now to the next one. So you have integral of ln x over x dx. Okay, this is pretty much like one of the ones we did before, right? Except that we don't have a radical. So again, we try to apply the only formula we have for fractions, du over u. Okay, well, now we have to choose, and we don't have too much to choose. So we have u equals x or u equals ln x. Which one do you think is going to work? Which one? U equals x or u equals ln x?
ln x.
Well, because there is not too much, you can do the du, and you know that this is 1 times dx. If you take du here, is 1 over x dx. So, which one of these two options give me the best answer? Is okay, let me see. Here I have the u is right here, but I have a 1 with the dx, and I have ln x with the dx, so I cannot cancel out this one. So, this doesn't work. Let me see the next one. u equals ln x, okay, it's right here. And du is 1x dx. Okay, I have this together. So this is a good option. So my integral, right? Integral ln x over x dx is going to be u, integral of u, right? Times du. How I did the grouping? Okay, I collect these two. This is the du. And this one is the u, correct? So it's what I did. Now, this is not this formula. Oh, but the formula is the power rule. So integral u to the n du, un plus 1 over n plus 1. Okay, this is u to the 1. Here is a 1, correct? So my solution is going to be u squared over 2 plus c, correct? Now, the only thing I have to do is substitute the u value. Okay, so this integral is going to be ln of x squared divided by 2 plus c. Okay?
Porque era u squared over 2.
Yeah. So no problem from here to here?
Yeah.
This step is clear? Okay.
Okay.
Then who's the u? The u is ln x, correct? So I have to put this inside the square, is what I did. That's my solution. Okay. Now, how can you be sure this is a solution? If you take the derivative of this answer, you must get your integrand. If you take this derivative, you must get that one. And it's obvious that it's going to be c in that way. Okay. Everybody fine? No questions? This is easy. Okay. Now we're going to turn the page. Yeah, so I'm going to be right here. So we solved these two. So we are going to solve now these little monsters. Look scary, right? But they are not. They are not that bad. So integral 3x squared plus x minus 1 over 2x cubed plus x squared minus 2x dx. Okay. Okay, here is my problem. Yep. Now I have to see again which formula is going to help me. Is well, I guess again it's going to be this one, right? Du over u. So my formula, let me just put it in green, is integral du over u equals ln u plus c. I'm going to try to match this one. So let's see. Options, u equals. Who can be the u? Remember,
2x to the third power.
correct. Remember the hidden rule in this problem. Because you are going to take the derivative of the u, if you select one u, the other one should be like the derivative. Now, this is not difficult to see. The derivative of x cubed is x squared. The derivative of x squared is x. The derivative of the x is 1. So it looks like that's the choice. 2x cubed plus x squared minus 2x. Then we take the differential. So we take the derivative 6x squared plus 2x minus 2, everything multiplied times dx, correct? Well, I compare, well, this is not exactly this 3x squared plus x minus 1,
It's divided by
but
1/2.
I can factor, correct? I can factor 2, and I have 3x squared plus 2x minus 1 dx, and I see now that this is this expression, the only is needing is a 2. Okay, so that's not a problem because I can put constants in the integral. So this is going to be integral.
Wait, Ramirez.
Yep.
Did you forget to take out a 2 on the second part?
Right here?
Yeah.
Yeah.
The 2x.
Yeah. Oh, yes, you're right. That's it. Thank you. So this expression is exactly this one. So I'm going to put the 2, 3x squared plus x minus 1 over 2x cubed plus x squared minus 2x, right? And because I put a 2, I'm going to cancel the 2 with 1/2 outside. So these 2's are going to cancel. So I have the same expression. And then I change my expression as 1/2 integral. All this at the top is the u. All this is u. And my solution obviously is ln u plus c. Now, the only I have to do now is put the u value. So this expression, so this is going to be 1/2 ln absolute value of 2x cubed plus x squared minus 2x plus c. So this is my expression, okay? So, well, not a big deal, right? So it's simple, it's the same procedure. Remember, what is your guideline? The formulas. You must memorize these formulas. Such a way you are going to see a way out for the problem.
En nuestra formula chart, ¿dónde están las reglas de los logs?
On the back of it.
At the back. The rules of the logs, if you have this one, right? They are in page 3. No, in page 3. If you open page 3, you can find them over there. And they are also in page, let me see. In page 7. In page 7, you have all the rules of your exponentials, correct? So page 3 and page 7. Yeah? Obviously, the formulas I'm asking you to memorize are at the back of the formula booklet. Derivatives and integrals. Looks overwhelming. It's not. These are equivalent. So you memorize this one, you can easily remember this one because are the reverse, correct? The derivative of the cosine is the sine, the integral of the sine is the cosine. The derivative of the tangent is secant squared, the integral of secant squared is tangent. So it's pretty much the same. There are some extras that we have to determine, but pretty much it's the same thing, okay?
¿Por qué había puesto 1/2?
Because I added a 2, remember? So I multiply this expression by 2, yes? So because I don't want to change the expression, I put 1/2. What happened with 2 and 1/2? They cancel, correct? So I get the same expression. Remember, the rule is do whatever algebra, but don't change your expression. The expression must be the same, okay? Okay, let's do now. This one. Yeah, let me see. Okay, this one right here. Okay, the integral of 2x squared minus x plus 3 over x plus 1 dx. Okay. Okay, let me just back to the board. This is the expression we're going to get that. Okay. Again, it's a fraction, right? So we're trying to use this formula. Okay. Now, again, we choose the u. We have two options, u equals x plus 1, u equals 2x squared minus x plus 3, correct? Well, are these good choices? Let's see. Du equals 1 times dx. Du equals 4x minus 1 dx. Okay, let's see the first one. I have here a 1. Okay, here is a 1 with the dx, but I have all this expression and I cannot move it out of the integral. So I don't know what to do with this big one. So, no, doesn't work. Second option, u is 2x squared. Okay, the derivative is 4x minus 1. I don't have a 4x minus 1 here and no way to put it. I have x plus 1 at the bottom. So again, I cannot find the expression. So none of these works. So if you cannot do this directly, what is my option? This is do some algebra, correct. Algebra, why? Because I have to change this by something else. One expression, two expressions, three expressions, something. Okay. Now, I have to analyze my expression. I have a quadratic divided by a linear. So this is, well, this is like when you were kiddos and you receive, for instance, 7 divided by 4. Okay. What you did in these fractions, let me just put it here, 7 divided by 4. Okay. What usually you did with this improper fraction? This is, well, what I did is I took the 7, I divided by 4. Okay, 4 times 1, 4. Yes, and then I express 7 divided by 4 as 1 and 3/4, remember? And then really this 1 plus 3/4. So this is just a shorthand, but not useful here in this class. This is the one that is the real important thing. So 7 and 1/4 is one whole plus 3/4. So this is the one we have to be aware. So everybody understand this? Yeah? If you divide a
Yeah.
big number by a little number, you can get an integer plus a fraction, correct? You see? This is the important part. When you have an improper fraction, you divide, you get an integer plus a fraction. Okay, I'm going to do the same. So this number at the top is more than this at the bottom, so I'm going to divide. So I have to do some algebra. Okay, let me just take x plus 1 dividing 2x squared minus x plus 3. Okay, now, you remember how to do these divisions, right? Well, that's the situation. Okay, the first one I divide this by this. Okay, 2x squared divided by x is 2x. I write it here at the top. And then I multiply and subtract. 2x times x is 2x squared, subtract. 2x times 2, 2x, subtract. Then I'm going to get a subtraction. This is 0, and this is negative 3x. Now what you do? You move down the 3, and you put it with this one, and then you divide this by this again. Okay. 3x negative divided by 3x is negative 3. Then you multiply and subtract. 3 times x, 3x. Positive times a negative, negative. Because you are subtracting, you get a positive. 3 times positive 1, negative 3. You subtract, you put a 3. And then you get, this is 0, and this is a 6. This is okay. So after this long division, right, we got that this expression, right, let me just put it right here. This expression, 2x squared minus x plus 3 over x plus 1. Let me just do this again. 2x squared minus x plus 3 divided by x plus 1 is, remember what I did in the division with numbers. 2x minus 3 plus 6 over x plus 1. Everybody? So everybody catch what happened? Same as here. Yeah, same as I did here, I'm doing here in this level. Obviously, this is when you were in 3rd grade. Now you are almost graduated. You have to be able to do this. Okay.
Si nos vamos a graduar.
Of course. Claro que sí.
De Zoom University, ¿verdad?
I don't know. Bueno. Okay. So this integral, so I'm going to make here my space now. So this integral is going to be the integral of 2x minus 3 plus 6 over x plus 1 dx. So you see, this big expression right here is now split in these ones, 1, 2, 3 expressions, correct? Now I'm going to apply my calculus. My calculus is going to be the integral of 2x dx. Well, let me just use the proper colors. So this is integral of 2x minus 3 plus 6 over x plus 1 dx. And then, well, now I'm going to use my calculus. My calculus is going to be the integral 2x dx minus the integral 3 dx plus the integral 6 over x plus 1 dx. Correct? So the part in red is the calculus, okay? The part in blue is my algebraic manipulation. So I did all this to find that this expression can be split in this. I did not any calculus. Okay, now antiderivatives. Antiderivative of 2x, that's easy, x squared. Derivative of x squared is 2x. Antiderivative of the 3 is the 3x, no problem. And this, well, this looks like this one, you see? The u is the x plus 1. So this is going to be 6 ln absolute value of x plus 1. And I'm going to put all 3 constants of these expressions in 1. And that's my answer. Okay, now, comparing colors. Check colors versus colors. I cannot apply my calculus if I don't do algebra, okay? My expression doesn't match directly this, so I have to do some algebra to split this expression in something that is solvable in calculus. This is going to be the difficult part, okay? Questions here? Long division, remember long division, everybody? It's important now. And then when we have our expressions, we'll compute antiderivatives. Okay, aquí está la otra hoja. Well, the next problem, let's do the next problem. Okay, it's going to be pretty much the same thing. I'm going to give you some minutes to solve this, but your is exactly the same as before. 4x squared minus 2x minus 3 over 2x minus 1 dx. Now, remember what you learned in your previous problem. If the expression at the top is greater than the expression at the bottom, you can divide this thing and change this one by something simpler. So, okay, long division. A ver, practice again this thing. Okay, you see the expression, you got the same?
Wait. Yeah.
Pretty much the same thing? Okay, now we are going to split our integral in two. So this is the integral of 2x, right? Minus the dx minus the integral 3 over 2x minus 1 dx. Okay, antiderivative of 2x. No problem. Antiderivative of this one. Now you have to suffer a little bit with the last integral. Okay, if you do the u substitution, and the u is this one, the du is 2. So the only need is a 2 right here, and put that 3 outside. So this is going to be 3/2 ln of 2x minus 1 plus c. Correct? Pretty much clear. It's the same procedure. All the game is right here in the algebra. This cannot be sweet with the formulas. We have to do some algebra. This is this greater than the bottom one? Division, and then these two expressions, split integrals, and then solve every problem. That's it. Okay. Okay, another one, and then we go to the homework. Integral of x over x plus 1 squared dx. This is going to be interesting because it's going to require a trick. So let's see if we can sweep the integral directly. What do you think? U equals x plus 1. U equals x plus 1 squared, or u equals x. Which one is your choice? You have two choices, you see? U equals x plus 1, u equals x plus 1 squared, or u equals u, x. Which one?
Is it x plus 1 squared?
X plus 1 squared? Okay.
It's in
One of the three.
Suppose you
Hey,
get this
Ramirez.
one. Yes.
¿A qué hora es la otra junta?
at 12.
12.
Ok.
Sí, ya se anda durmiendo.
Es que se me va a acabar la batería, así que lo voy a ir a cargar. Ahí regreso para las 12.
He's playing Minecraft.
Okay.
Ahorita lo puso en el teléfono.
Okay. These are the three choices. You see? This is man. I have some trouble. I have to select one. Which one looks more suitable to work? Well, let's see this one. If you take this, the u, the top one, you have an x plus 1 squared that you cannot fit here. Okay, so this is discarded. About this one, right here, if you take x plus 1, all the u, you have at the top 2x plus 1, and you have only an x. This is man. And if you take this one, you have only the dx. So in one, I have this x extra, and here I have a one that I cannot find really. So let me just try the first one. Yeah. So if we change the integral with these parameters, I have integral of, and I'm going to put here, x over, aquí, parentheses, x squared. I'm going to put here the u, and then the du. Well, let me just use the red, really. U, and then the du. Okay? So I'm using the first one, so I change the du by dx, the dx by du, and then change the u by this one, and I have u squared. But my problem is this one, x is still there. How can I change the x by u? So change x by u is possible? Okay, check your formulas. U equals x plus 1. Is possible to change the x by u? This is if u equals x plus 1, x equals what?
U minus 1.
U minus 1, that's correct. Okay, so, okay, not a big deal. So what I can do is this integral is equal integral, and then I'm going to use my u minus 1 over u squared du, correct? So I change my integral by this one. And now this one is exactly one like the ones we solved before. So you can distribute the thing, and this is simply integral of u over u squared minus 1 over u squared du. Then this is equals integral 1 over u minus 1 over u squared du. Well, not a big deal because this is directly this one. So this is ln absolute value of u. And this one is the integral of u to the negative 2 du. And I'm going to use the power rule. So this is ln absolute value of u minus, well, no, this is going to be plus 1 over u plus c. Why 1 over u? Because if you add 1 here, negative 2 plus 1 is negative 1. So this expression over negative 1 with this minus is a plus. Now, what is the last thing you have to do? Well, I have to return the u value. So this is ln x plus 1 over x plus 1 plus c. Okay? So check all the process. We have an expression. We try different substitutions. We select one. Okay? We do the changes, and we saw that we have an x that we cannot cancel, but this is, well, if the u is x plus 1, then the x is u minus 1. So I change this using the same expression. I change it here. Then I use some algebra with calculus, and I solve the problem. Okay? Yeah. Challenging, right? Everything you learn has to be used here. Bueno. Before I move the screen, any question? No? Everybody's still alive? Okay. Let me just check now the homework here. This one. Okay. Somebody was asking for this one, correct? So this was not problem. Remember, this is more than the bottom one, so you have to do this in the long division, split this into expressions and do the integration. Now, what about this one, right? What about this one? Really, I'm just going to ask you to do which one? Let me see. 1 minus x squared. Possibly this, I'm going to subtract. Okay. Please don't do E. Skip this one also. We're going to focus on something like this. Correct?
La tarea is page number 6.
It's in page number 6, 5 and 6, right? So here we're going to skip this problem, G, because it's trigonometric substitution. So don't do this. We're going, I would like you to try this one, right?
Wait, no lo tenemos que hacer como...
No. Problem G, no.
So just to
Forget
do
this one.
any
Forget this one.
Como la tarea,
Forget
no lo
G.
tenemos que hacer like at all.
No.
¿La cuál?
Problem G in page 6, this problem. And
We can
problem
try F,
E
but we
in
don't
page
have
5.
to get it right.
Possibly
So we can
you
try
get it
F,
right.
but we don't have to get it right.
But this is trigonometric substitution. It's no longer in the scope and sequence of calculus AB. So as I told you, I have to correct many of these assignments, right? So the only one we're going to ask you to do is C, B, A, and D. But I'm going to solve this with you. This one, F, is the challenge. Let's see who's able to solve this one. This is possible, okay? This is possible.
F?
Yeah, F. So let me just go to D. Let me just solve this one. This is going to be long. So grab a blank piece of paper, big enough to hold all this one. So we have integral 0 to 1 x minus 1 over x plus 1 dx. Okay, stop sharing. Okay, now that's my problem. Okay, now this is a definite integral, remember? The definite integral in calculus was this one. If you have to integrate from a through b a function, what you have to do is find the antiderivative of the function, this one, and then you evaluate from a through b. This is f of b minus f of a. This is what we have to do. So we have to solve this one. You have to find the antiderivative. And once you have the antiderivative, you have to evaluate this antiderivative in these two limits in this way. And then you find a number. Okay? So this is going to be our way. Now, let's focus on this one. Let me just focus in the integral x minus 1 over x plus 1 dx. Correct? Okay? Now, x minus 1 over x plus 1. Okay. Now, what is the formula we can try to fit? Okay, again, du over u, right? Now, I have to do u equals x plus 1 or u equals x minus 1. What do you think is going to work? The bottom one or the top one?
X minus 1.
Ux minus 1? Well, let's see. Du is 1 dx. Du is also 1 dx. They are the same. Now, check your expression. Yeah, here. 1 dx is right here. So for the first one, I have to work x minus 1. From the second one, I have to work with the denominator x plus 1. Now, if you have to choose what number you want to work with the numerator or with the denominator, which one is simpler? Top one?
Denominator.
Denominator or numerator? Which one? So which one of these two you select?
Denominator?
Denominator is a good idea. Let's see. Let's suppose we choose this one. So my integral, right, is going to be integral, okay? So I'm going to do in blue, right, what I was able to change. So is x plus 1 is the u, correct? This is x minus 1, and this is the u, correct? Now check the colors. For this integral in red, I'm using this substitution in blue. So the u is x plus 1, so I change this portion as u. This is the x, the u. And now I have to change x minus 1 in terms of u. Yeah. So, entonces, if u equals x plus 1, x minus 1 equals what?
Yeah.
A ver. Let's begin and work with the expression we did the u substitution. U is x plus 1. We have to continue with that one. It's like marriage. You cannot divorce. You have to continue together until the end. So x plus 1, u equals x plus 1. Okay, I changed the x plus 1 by the u here in my expression, the dx by du. And the only thing I have still in red is x minus 1. Now, again, I began with u x plus 1 and I need x minus 1. So if u is x plus 1, what is x minus 1 equals to? Fíjense bien, this is basic algebra. U equals x plus 1, so x minus 1 equals what? What you can do here to get an x minus 1? What you can do here in this expression to get x minus 1? Yes?
Can you factor out a negative one?
No, factor is for multiplication. Here you are adding or subtracting, you see? Check. You have x plus 1. How do you change this x plus 1 in x minus 1? What you have to do? Subtract what?
Puedes-
X.
How
No,
much?
Oh, subtract 2.
Correct. If you have
Oh,
x plus
smart.
1, to get an x minus 1, you need to subtract 2 here, you see? So it's like this. U minus 2 equals x plus 1 minus 2, correct? And then you get x plus 1 equals u minus 2, correct? So everybody, let me just put it right here. U minus 2 equals x plus 1 minus 2. So x minus 1 equals u minus 2, correct? Okay, everybody? So again, I'm playing with my algebra, okay? But in the u substitution. Now, okay, my integral now in red is going to be integral u minus 2 over u, yeah, du, correct? Now, this integral is equivalent to this one, but I have something to do. The integral original has 0 and 1. So these are values for x, and this is a u. So what I have to do is change values 0, 1, really some is change x values 0 and 1 for u values. How can you do that? Again, you use the same substitution. If x is 0, u is 0 plus 1. Why 0 plus 1? Because u is x plus 1. So the u is 1. If the x is 1, the u is 1 plus 1. Why? Because u is x plus 1. So the u is 2. So this integral that really goes here, 0 to 1, 0 to 1, here is going to be 1 to 2. This is extremely, extremely, extremely important. If you change the variable and the variable has values in the definite integral, those are x values, you have to change those x values into u values, because if you don't, you are going to evaluate a different problem. So this is the whole thing. You have this integral in x. So these s0 and 1 are x values. You change your variable to a new one, u. Okay, you did all the process, you suffer a lot. Once you change all the x by u's, like here, you have to change also the x numbers 0 and 1 because these are x's. You have here u's. So you have to change these numbers into u values. How do you change them? Use the same formula you use for the u substitution. If u is x plus 1, when the x is 0, the u is 1, 0 plus 1, 1. And when the x is 1, the u is 2, 1 plus 1 is 2. This expression the same. Then, okay, here comes the third part. The third part is, this is the integral from 1 to 2 of u over u is 1 minus integral 1 to 2 du over u. So I'm going to split this when u over u 1. Let me just put the 1. And 2 over u is over there. I'm going to put here the 2 outside. Okay? So I'm going to change this by this, right? Now, what is the antiderivative of the 1 is the u, and now what you're going to do is evaluate from 1 to 2, minus this is the natural log, it's right here, so it's twice ln of u from 1 to 2, and then the only you have to do is make the difference, 2 minus 1, minus 2, ln of 2 minus ln of 1. Well, let's have just not too much more here. 2 minus 1 is 1. ln of 1 is 0, remember. ln of 1 is 0, always. So this is minus 2 ln 2. This is my answer, correct? This is my answer. Okay? So this is the way we solve definite integrals. Remember, we did definite integrals in the first semester. Yeah, this is long, correct? Integration is more difficult than differentiation. Okay? Well, remember, I'm going to load this video into in my YouTube channel, right? So you can check this process again if you want, right?
Happened to
And
David.
did you have any question, right? Just
Sir, Mercy, a little bit more to
send
the
me a
right.
remind and we can possibly set up a tutorial session quickly, depending how's my time. Okay, so if you have any questions, just remind me. So send a text message with remind and we can work again.
Mañana también va a ser estos.
Okay, so don't forget the homework, please. By this Saturday, take a picture and upload to your Google Drive and share to me. Remember the address, mramirez2@gpapps.galinaparkisd.com. Okay, it's pretty much the same one you know. mramirez2@gpappsgalinaparkisd.com.